Hello and welcome to Engineering with Rosie Live. Today we're going to be talking about sustainable buildings with David Gottfried, who I will introduce properly in a second, but we can all just quickly say hi. I have a question for people watching. Can you put in the comments? We're going to be doing a rapid fire round on sustainable building innovations towards the end. So I've asked my Patreon team ahead of time, and I've been through the comments on my recent video on cement and gotten some ideas for sustainable building innovations, like replacing cement with timber or hempcrete, for example. So to add to that, what innovations do you want to hear David's opinion on? And I always like to hear where people are watching from, and what brought you to the video today? What's your interest? So I've just got to start by thanking the sponsor of these live streams, which is WeatherGuard Lightning Tech. WeatherGuard makes Strike Tape, which is a retrofittable lightning protection system for things that go fast, like wind turbine blades and aeroplanes. And Padloak Consulting, which is my company. We provide consulting services related to energy transition technologies. So that includes any kind of advice and research on energy transition technologies and how they all fit together, through to technology due diligence for clean tech developers and investors. And the whole channel is supported by the Engineering with Rosie Patreon community. So if you want to join the team, then there is a link in the description. So onto the proper part of the live stream. Today, we've got a real heavyweight of the green building world joining us. So meet David Gottfried. He's the genius behind the US and World Green Building Councils, and the Australian one too, I hear, which developed the LEED rating system, which if you're not aware of it, then you have almost certainly been in buildings that are certified according to it. And David's now the force that's driving sustainable change at Blue Planet Systems as their global chief global impact officer, wrong way around. So let's hear more about your background, David, and tell me if I got any of that wrong. Is that a pretty okay summary?
Yeah, I can't take credit for the Israel Green Building Council, but I did attend their conference in Tel Aviv and got to use my broken Hebrew to discuss green buildings, so that was fun.
Well, I think you can say it's safe to say that you have had a big impact. It's easier to pick out the ones that you haven't been responsible for on a global scale.
Certainly a lot in Australia where you're from.
That's good. We can do with some help in that matter. Actually, I lived in Denmark for 5 years and came back during the pandemic. Denmark is obviously known for having hard winters. Australia is known for the opposite. I have moved to the coldest city in Australia, Canberra, but I will tell you that it's a shock how freezing cold it feels suffering through a Canberra winter compared to a Danish one, and the difference is the building quality. So we've got more work to do here, but anyway, let's go back a bit. So you got your degree in engineering and resource management from Stanford University in the 80s, right? So yeah. Can you just tell me, how did that lead into sustainable buildings? And I mean, you're the father of this industry, so I'm assuming it wasn't like a big established field back then. So what was the industry like, and what led you to see the need for change in this space?
I was very lucky, and some of us were lucky in university or even earlier in school to have a mentor. And when I was at Stanford, they had Professor Gil Masters, who is in civil engineering, and he taught a solar class. And many, many decades ago, I have some gray hair. I hate to say how many, but he had a solar class, and I signed up for that. And we had a project to design our own net zero home, and build a little model and scale it and size it. And we also at Stanford had Paul Ehrlich, who taught about population and carrying capacity of Earth. And between the two, I woke up and realized, hey, one, there's a sun and it can do a lot. Two, we consume resources beyond our carrying capacity on Earth to sustain. And three, why not use your career to do something about it? And so it was just incredible underpinning for a future in green building. And out of that, I became a real estate developer in Career One for 10 years in Washington, D.C. And I learned the vocabulary and how buildings are developed and financed and built and sold, and the construction and property management. And it all just came together.
Right. So it's interesting that you would, start so early in your career, kind of forging a new path. How long did you do the real estate development thing before you struck out on your own?
That was 10 years, and it was the green part of it was make as much money as possible, which is fine, but we weren't exactly calculating embodied carbon and scope 3 emissions, which those discussions didn't even exist in the early 80s, but those 10 years were phenomenal to parlay and be able to speak the vocabulary of our industry as you overlay sustainability into the conversation.
Yeah, and back then, so I mean, I guess we're talking if you're at uni in the 80s and then 10 years of work experience, so now we're in the 90s. That was probably the earliest that I was aware of the idea of climate change. I mean, I was still a kid then at school, and my dad had a New Scientist subscription. And I know from time to time, they would be talking about global warming, but they would also be talking about potentially a new ice age at that time. So was global warming the driver? Is that sustainability now usually is, at least the bulk of it means global warming or, minimizing global warming. Is that what it meant back then, or did it mean something different?
There were waves. So in the early 80s, we were just starting to do recycling and separating glass and cardboard and other usable materials, and used to put in your car trunk and drive it to the recycling place for separation because they didn't even pick up at your door. A few years later, indoor air quality became an issue in the 80s. When, particularly in Washington, D.C., where I was the EPA headquarter building installed carpet with this adhesive that was off-gassing and making the EPA, Environmental Protection Agency, employees sick, and they refused to go to work in the EPA building.
That's ironic.
Yeah, and they sued them, and it was successfully settled. But it was one of the first cases on indoor air quality. It was the EPA's own building. When I grew up in high school in Los Angeles, we had a water crisis, and the aquifers are drying up, and Sydney had that on a lot of my trips there in the hotel. They had these little egg beat timers of 3 minutes is what a shower should be, and people were filling up their bathtubs with bath water, or taking the bathtub water and putting it in their toilets and their landscaping. So green building in the beginning, which for us was the early 90s, when I started to work on the U.S. Green Building Council, was gluing together those waves: recycling, air quality, energy efficiency started up as well. Early on, we had the ozone hole and the cancer caused from that. And that was even louder volume in the early days than climate change. And then everything shifted to climate change. But there was also diversity and health got into the equation as well. We're starting to lose all the sounds of those instruments in the orchestra of sustainability as the weighting changes, but there were a lot of waves.
Yeah. Okay. I have questions, but I'm aware that we've got a lot to get through. So let's keep pushing forward. So what did you do then? I know that you were partly responsible for setting off the process that led to the LEED certification. How did you do that? And can you tell us what that certification standard means? And I think I have a screen up I can show.
Sure. Well, I founded the U.S. Green Building Council. I had two co-founders, Rick Fedrizzi and Mike Italiano. We kicked off April of '93. I wrote a little white paper that the U.S. needs a green building rating system. That was in '93, way before LEED kicked off. There are two rating systems in the world at that time. The first to study still exists and is prominent is BREEAM out of the UK, and it's now run around the world. The second was in Canada, out of the University of British Columbia, but it didn't actually take hold. We studied those. We thought we would do one in the US. We created a committee under the US Green Building Council, which became Leadership in Energy and Environmental Design. We were lucky to have Rob Watson as chair of LEED for many years from NRDC, the Natural Resources Defense Council. The government, the DOE and EPA gave us big grants, which got us going. And LEED took off with a pilot around 2000. And then it started with just commercial new construction. Later years, we made it core and shell, the outside of the building, and then commercial interiors, and then operations and maintenance. These all became separate versions of LEED that you could glue together. LEED for homes, LEED for neighborhoods, LEED for cities. It became a whole system. We created the LEED accredited professional.
Okay, and so
yeah,
what is LEED? What do you do? Like, what's the rating look like, and what do you do to get a better rating?
So LEED, as in the other rating systems like BREEAM in the world, and there are many others, they generally have 5 to 8 categories that define green building. And there are levels of performance, such as our highest LEED Platinum. We even have an overlay on that. You can get Platinum and then Net Zero. But in Australia with Green Star, you have 5 stars, 4 stars. Japan has CASB and China has 3 star. But they're all weight the categories, most important being what you said, climate change, energy efficiency, and the weighting on that. They have water, they have health, they have resources. Yes, so you see them here. Transportation is very important. Diversity is starting finally to get into the equation. And when you look at energy efficiency, the embodied carbon, that first carbon of building the building, is now gaining more weight in the systems. And the key is to maximize all those areas to get the highest rating you can get, to design it green, build it green, operate it green, and then do continuous improvement green.
Okay, so this might be a good time to raise, I've got some questions ahead of time from my patrons. And one of the questions that I got, maybe a couple of them relate to this. So one of them is actually from the Discord server that we have for the Patreon team from Breadroll. He says, I sometimes wonder if it's greener to repair a structure or demolish and build with new technologies and materials. Everything seems to be torn down entirely. Should we aim to build stronger core structures and reuse them later? And that's a question that I'm looking to buy a house at the moment. And we were discussing before the stream about how terrible the energy efficiency of Australian homes are. And everywhere I look, there's houses that have zero stars. It's really hard to see how you're gonna bring it back up, and certainly it would be cheaper to just knock it down and start again in many cases. But what's the environmentally correct thing to do? Assuming that you have a poor design to start with. There's so much, obviously embodied energy in that building, but when do you decide whether to knock down and start again, or should you always try and reuse?
It's a great question. It should be the first question in what you're doing. There isn't one answer. It depends almost on a case-by-case basis. It depends on that existing structure. If the roof height is too low and you'll never have quality space, sure, you could take it out. But if you're going to put a ton of money in something that'll never be, high quality, then that could be wasted money. What we're talking about here is the energy and the value of the embodied carbon, those resources that are embedded. And you can calculate that. What is the embodied carbon that if you save that structure, you'll retain versus the demolition, the transportation of demolition, and all those new materials to replace the facade and the roof and the foundation. You can calculate that. And then you could look at the operational energy. Could you renovate that existing high embodied carbon retaining structure, but what's the operational energy over the next 30 years versus demolishing it, that high waste, but then super efficient? And you could do a calculation on it. But I would start with the quality of the space, and you don't want to throw a ton of good money at bad money. Nevertheless, one of the projects I did is a 1915 Craftsman bungalow in the Berkeley area of California, and it had no insulation in the walls, lousy windows, bad roof, not much daylight. So a lot of handicaps, but at the same time, we were able to retain that whole base structure, blow in cellulose insulation, put in dual pane windows, do solar and hot water, and also photovoltaics, and change all the appliances and systems, and do gray water and black. We didn't do black water, but gray water and rainwater. And we got it up to the highest level LEED Platinum in the world for about a minute till someone else beat us. But even that renovation beat all the new construction. But it had a lot of limitations. If I could start from scratch, we could have done even better, because you could only super insulate the walls so much. You had to find windows that fit the existing dimensions and looked Craftsman. So it's a debate, but you should always look at what you have and try to save it. As a first requirement of green is always, restore first, recycle second, reuse before you demolish. And if you demolish, then sort and separate and try to put those as ingredients in a cradle to cradle format.
Yeah, okay. That kind of leads me to another theme that emerged from both the Patreon and when I asked on YouTube as well, is about housing density. So, we usually, I watch Grand Designs and I like the eco houses that they do, but they're always, standalone homes, and people like me, I think a lot of my viewers as well, kind of aspire to having a really eco standalone home. But you mentioned that transport and walkability were important factors of sustainable houses, or maybe I'm interpreting what you said, but I felt that you were saying that was important. And so do you think that medium high density housing is the most important thing? Are we kind of, people like me, barking up the wrong tree when I imagine a nice green home and lots of plants around and space and light coming in through all my many windows? Is that just a naive view?
Well, density's essential, because a lot of places like Singapore were running out of, or Hong Kong were running out of land. And you got to stop the sprawl where the car becomes king. Of course, you get a public transit, but density is very important in going up. Excuse me. There's a big cold going around, and unfortunately I haven't. But I once did a study looking at high-rise construction, and you find, as you go up, the square footages actually get smaller in your residential unit. The energy efficiency goes up, your water efficiency, your transport efficiency, because if it's a dense area, you can walk somewhere and get a coffee, get your food. Hopefully there's public transit with metro, bus, rail. God forbid you could walk to work and things like that. And certainly we're working at home now. So the ecological footprint as you go up goes down. However, if you do have to drive and you build these new neighborhoods, you can certainly do net zero and regenerative housing. But as things get big, there's a bigger footprint and a higher price to pay. There's also something like a walk score, which is how many of the essential services you can get out the front door. So I'm a huge fan of density, and that is the solution. And trying to revive our urban cities again, so they don't just empty out, and make them vibrant. And there's a lot to be said for that. I just moved to a downtown myself, got rid of the single family house, and I'm just loving walking everywhere. And my unit I'm in is a third of the size of what I had. And you don't need that much. You don't need all that stuff. What do you really need? You need a quality of life. You need health. You need people and community.
Yeah, okay. That's a good place to move on. I know I'm already letting us get behind time, because one of the things that I wanted to talk about was, the most recent video I released on my channel was about concrete and where the emissions come from in there. And that's actually talking to you about that was how I originally got in touch with you. In my video, I basically said, the easiest or the best thing to do is to, first of all, use less. And then secondly, there's technologies that can reduce emissions. You're working for Blue Planet now, which is, concrete rather than cement company, right? So I didn't mention Blue Planet in the video, but I did want to get you on to talk about what Blue Planet's doing and, why you joined on to, make that the next part of your sustainability journey.
Yeah, in my path, maybe like yours, I'm always looking for pieces to put into the puzzle of sustainability. And if a lot of the pieces are coming together, I'm not staying with those pieces. I'm looking for the gaps. And one of the biggest gaps I could see was embodied carbon, that energy to make our structures, or also our airports and our metros. And concrete is 8% of global emissions. And that's the biggest problem in the new construction. We were doing pretty well with operational energy and getting that down, and solar and wind. But on the concrete and steel, we're really struggling. And I had freed myself up selling my last company, and I was on the advisory board of Blue Planet for 8 years, and a prior company with the same CEO. And they had this Blue Planet University for the advisors for 3 hours. And even though I had been involved, I didn't quite get the impact of it, that it was a gigaton impact. And that what we were doing was mimicking just what you see there, what the oceans were doing. And that the biggest CO2 absorbers on Earth are the oceans, and making the lithosphere. But the lithosphere of the future, just as the oceans suck in the CO2 and make the coral reefs, concrete above grade could be the lithosphere of the future. And that the calcium carbonate that is taken, that's made out of the oceans and made the limestone and the reefs, could be done in our concrete. And that calcium carbonate could be in the cement, but also in the aggregate. And aggregate is 70% of the concrete and 44% of that rock. And the sand and the fines could be sequestered CO2 from industrial sources. And so there's this beautiful synergy between capturing all that CO2 that's going up into the atmosphere, or even using what the DACs are doing when they're sucking up the CO2 in the acquisition of it. We could use that as well. And we could make synthetic limestone that looks like coral reefs, the same calcium carbonate. And we could put that into our concrete, and it could be 100% of the aggregate and the coarse and fines. And 44% of these white rocks could be sequestered CO2, whether it's from natural gas, from coal, even from blue hydrogen. When you split the methane in SMR, there's a ton of CO2, and that's the problem. And that can be sequestered and embedded in these white rocks. And aggregate is the second most used substance to water on Earth. And it's an unlimited reservoir opportunity. So I went from advisor to full-time pusher, accelerator, pushing of the concept of Blue Planet. I'm pushing us internally. I'm trying to educate the whole building marketplace of this opportunity. And I'm trying to work with our firm and other future off-takers to commit in advance with off-take agreements and advanced market commitments to demand this, so we can build plants all over the world now, not tomorrow. We need this now. We need to capture that CO2, put it into products, and use it. And the key is that U in use. It's utilization. This is CCUS, carbon capture and utilization and storage, not just capture it, purify it, transport it, great energy cost, and put it in the ground. We need to use it in products.
Yeah, so this is a topic I've talked a little bit about on the channel. Did one video on CCUS and looked at all sorts of things from, making diamonds and alcohol at the, gimmick kind of end of the scale through to things like mineral carbonation and biochar were at the, more practical level. And one of the things, or probably the main metric that I use when I'm assessing these technologies is can it scale? Because we have to remove gigatons of carbon from the atmosphere. We don't measure, there's a reason why we measure the size of diamonds in carats, not in tons. We're never going to need that much. So how does the Blue Planet system? Let's kind of get into some technical details if we can, to the extent that you can answer them off the top of your head, and no problem if you just refer us to the website. But number one, how carbon negative does it become? So currently concrete is an emissions source. You're turning it into emissions sink. What's the balance? How emissions negative does it go?
So the Portland cement is the problem with the concrete. That's where the global warming potential is occurred, because they burn the limestone and create the clinker, very high degrees, like 2,000 degrees Fahrenheit, and also as you burn it, it releases CO2 itself from the product, and you hit a global warming potential of something like 624 pounds per cubic yard. That's what you have to offset. And obviously some of us know you can use these SCMs like fly ash and slag, and they can go well over 50% replacement for the cement itself in the overall concrete. And that cement is about 15% of the concrete. As I mentioned, the aggregate is about 70%. So you can lower the cement itself doing those things. Maybe if it's 624, you can get to 400 or 350. I'm hearing of 100% SCM, so those are alternatives, but they're not primary. It's also a limiting factor. It's harder and harder to get fly ash and slag. And there are other methods and innovations to lower it. But with Blue Planet, you can go at that 70 to 75% of the rock in the concrete. And as I mentioned, at a theoretical maximum, that could be 44% sequestered CO2 from industrial sources in it. So you can go well beyond carbon neutral into the negative, and you can get to a potential of -500-600. So that the concrete, as you see there, is an offset for the other embodied carbon, say in steel and other building materials. There's the 624 you see of the Portland cement. And this is without SCM. So if you went 50 or 80% SCMs, this would go to -800 and start offsetting the other building materials, hopefully getting, if you use a lot of concrete, getting the building to be zero embodied carbon, which would be phenomenal. And maybe even further, maybe the building can offset operational energy too and be used in the overall building net zero calculation that has operational carbon scope 1 and 2 plus the embodied scope 3. So that's the potential, and it's monstrous because it's the aggregate and much bigger than the other plays that I had seen in other technologies, which is why I'm there pushing.
Yeah, and I definitely, when I looked at all of the different kinds of carbon sequestration or usage, this was one of the few where I thought, yeah, I can see this having a big impact. But where are you at in terms of scaling up and cost? Because I mean, I think that's the hardest part about concrete is that it's so cheap, right? So it's really hard that any new technology could compete because I mean it's practically free if you look at the cost per ton. So how do you see that playing out? Is it going to be cost competitive, or do we need certain regulatory sticks or carrots to actually make this work at scale?
Yeah, we're trying. The business model at Blue Planet is not based on subsidies. And so to really scale this with hundreds of plants all over the world, you can't go to certain countries that are third world and they don't have any subsidies. They don't have a Biden IRA bill and the 45Q giving us potentially $65 a ton of abated CO2. But it is not going to be sold at the commodity concrete price either, because it's not apples to apples. Yes, you can replace the concrete and the aggregate, but it's also a carbon sink. So you don't need to buy offsets. And so it's two things. It's the commodity product that you wanted, which is called concrete. It's got aggregate, but it's also an offset. It's a concrete offset. And you're trying to get to net zero and offset your embodied carbon. And so it's got a duality to it. And there's a value to that CO2 because a lot of these firms are buying offsets to get to net zero, and they won't have to do it just by pouring Blue Planet concrete in the future. We don't have a firm price because we're not commercial. We're in our 12th year as a company. We built a pilot global demonstration plant in Pittsburgh, California. It's running. It's got a pipe tapped under the street to a Calpine natural gas plant. We're taking their CO2. It's reacting with a geomass. It has calcium oxide to make these white rocks you see, calcium carbonate. And now we have a concrete lab. We're testing these in cylinders like this. This is a 4,000 PSI cylinder. And we need to do all the testing and then compliance with the ASTM and ACI standards. And that's the state we're at. We're testing it with different mix designs, with different compressive strengths, with SCMs. And we're planning and raising the money for scaling that plant, as well as looking all over the world with some really large partners to license the technology to them, such as a Wholesome for their 270 cement plants. They're a partner investor. They haven't done those plants yet, but we're pushing along. We've got Mitsubishi as a partner, and other big investors who can help us scale. So the potential is quite great. We're still early on. On the price, though, we'd like to look at the commodity price plus the value of the sequestered CO2 in that local marketplace. However, if we did get incentives or paid at the front end from the polluter, then the price to the buyer could be lower. So it's a regional answer based on the economics of that plant and the negotiation with the emitter of the CO2 and that region. What's the value? New York City's got its own price of carbon that's quite high. Canada's got a price of carbon, but other areas are in the voluntary market, and it's the Wild West.
Yeah, well, I think, there's so much controversy around carbon offsets at the moment. And anyway, when you think of the end game, there's no offsetting that's going to happen in the end other than carbon negative emissions, right? You can't, offset by putting in a a wind farm somewhere, because wherever you're putting it is going to have to get to 100% renewable, zero emissions from their electricity anyway. So where do they get their offset to make up for the one that they sold you for their, and I should do a whole video on carbon offset sometime, but I'm becoming more convinced that negative emissions is the only thing that should be funded for offsets anymore, because of, where we're at. We're planning out the end of the energy transition, not just at the very start where you can take an offset from someone who was never going to do anything, because everybody has to do all the things now.
Yeah, no, the offsets are the Wild West, and having standards for them, having them verifiable, and ensuring there's not a shell game where they're double and triple counted. You can only count that asset of CO2 sequestered once.
Yeah. Okay. So let's move on. But I just have one viewer question that I wanted to raise about Blue Planet from SatNav. Very cool profile picture. Likes the process. What happens with it long term? Does it degrade or change its chemical compound after a time? Because that was a comment, a criticism all people had about my cement video, was that, I talked a lot about the carbon dioxide that's emitted when you turn the limestone into lime, but didn't mention that as the carbon cures and over time it absorbs it back. So how does that process happen for Blue Planet's products?
It's not going to degrade. I mean, it's calcium carbonate, just like limestone. It's sequestered. It's not off-gassing. So even if there are pollutant criterias in here, the heavy metals, they're not going anywhere. It's similar to the limestone and the aggregate that we're using now. So it's not something that's just going to react and evaporate. That's my understanding from our scientists. It's as permanent as concrete's going to be.
Yeah. Okay. All right. Yeah. There's so much to talk about, but let's move on now to our rapid fire round. Otherwise, we are at risk of missing it. So I'm going to just mention a bunch of sustainable building technologies and topics, I guess, and just in one sentence, can you tell me your opinion on them? And if there's any viewers that have one that they want included but haven't written it in the comments yet, then do that. So first of all, and I have some pictures to show about this as well. So first of all is earth sheltered buildings, and I have brought up some pictures of these ones. So Hobbit holes, somebody in the comments on this live stream called it. There are pictures on this site somewhere. Yeah, here. So here's some earth shelters. That's a good proper Hobbit hole. This one's in Iceland. They look nice and traditional and snug. There's also one in Canberra where I live that was on Grand Designs Australia, which, looks nice, but I mean, I worry about the daylight. And I know when I saw a Grand Designs episode on one of these in the UK, what's his name? Kevin McLeod used the word dank about 50 times in that episode. Wow. I don't think that the building ended up dank, but that was his like, isn't it going to be dank? And that's kind of the vibe that I feel like I get from it too. So anyway, I've talked too long. What's your opinion about earth shelters?
Well, you've hit one. They can be phenomenal, but the key is the daylight, as you hit. We need daylight for circadian rhythm. At the same time, when you go 10 feet below the soil, it's at a steady temperature of about 58 degrees Fahrenheit, and there's an incredible energy benefit in the insulating capacity. So I love them, but I also love daylight. So how do you bring it in from the top or through tubes and tunnel? And you can bring daylight in through tubes. So you got to mix the two, in my opinion. But I wouldn't throw it out. They're still cool.
I think it would be nice if you had suburbs where everybody was in these kind of earth shelters, and it would look like a very nice vibe compared to the, like just concrete cubes that pop up in all the new suburbs around here. That would be nice. It would just be fields. You could run through the fields over top of people's houses. Anyway, let's move on. The next one is biosolar roofs, which let's see if I can bring up this image. Basically, a green roof with solar panels on top. So the green roof, I guess, is similar to the earth sheltered building. Have you seen this technology? This was another one that was raised by one of, or maybe two of my patrons. There's a demonstration building in Sydney where they're comparing regular solar panels on a roof to a green roof of solar panels, and it keeps the solar panels cooler and improves their efficiency. What's your instinctive feeling about this?
I love it. I want it. We should have both. We should have vegetated roofs. We should grow food on the roofs and have solar. And if they can go together, I mean, just look at the aesthetics of the left to the right. I can breathe on the left. The right feels so harsh. And plus there's a insulating property for the landscaping beyond the fact it's pulling in CO2 and good for biophilia.
Yeah, I love the look of it too. Okay, cool. Next, Ply-Scrapers, or wooden skyscrapers, replacing concrete with timber instead. What are your thoughts about that? And I guess this image, it raises my concern is every time people talk about, increasing the use of wood is, can we guarantee sustainable forestry really is sustainable? Do you have any thoughts about that?
Well, deforestation is real. So is it a certified process of growing the wood? Is it, certified sustainable? That's what's the source? You got to start there. The other is what's the height limit, because you have some structural issues, and they're also sitting on concrete foundations. So you still have concrete involved. The key of the wood, beyond the aesthetics and the embodied carbon, which is monstrous there, but it's also because concrete is bad, or was bad before Blue Planet and other concrete technologies to lower the GWP of concrete. So if the future of concrete is going to be good, they can play together. This was an alternative, and tech firms are stockpiling it, but that's because concrete was the worst offender for embodied carbon calcs. Second was steel. If that game changes as a Blue Planet gets into the marketplace, that will impact looking at the timber. I'm not saying you shouldn't use the timber. I like the two together aesthetically. They're both help substantially with embodied carbon. I can see a nice synergy personally playing together, but I've heard there are limits of how high you can go in other issues, but it's still a neat material and a work of investigation. But keep in mind, concrete of the past will not be concrete of the future.
Yeah. Okay. And then a couple of viewers have raised some obvious risks. Jim Bob says a towering inferno. Serial Zombie says Fire of London flashbacks. I did actually read somewhere that people were trying to say that their timber skyscrapers were better in risk of fire because they maintained their structural strength for longer than steel did. I know we all probably are aware of in the September 11 tower collapses. One of the problems was it got really hot and the structural steel softened. So that's definitely the obvious risk, but at least some people think that it's going to be better for fire point of views for skyscrapers, at least.
There's fire ratings, for the buildings and the materials too. So everything has to meet the code and standards.
Yeah. Okay. So another one from viewer here, Satnav again, Cob Housing, which is another one that I see a lot on Grand Designs, and I personally hate it. I just hate how Cob Housing looks, and I hate every house that's made from it. It's maybe that's a little bit of a immature attitude. What do you think about Cob Housing?
I'm not an expert there, but some of these alternatives are interesting. But can you do high density housing, as we were talking about? Can you hit gigaton impacts with it? Can you educate the large construction industry on how to use it? I was involved in some rammed earth ones, which were neat, but very few contractors wanted to do it. And
They always seem to involve semi-enforced labor. These projects like that on grand designs, they've always got camps of people who are working for free or for the knowledge, or they've roped their kids in, or
getting
like
the building permit. And what if you have 3,000 units you have to build? But I'm still interested in these alternative technologies, but can they scale? And the real key here, we'll get to it towards the end, is we need massive sequestration with urgency. And so if things can't get to a gigaton fast, we don't have the luxury of time given the heating up of Earth, and that we're at 420 particles per million, and there's no way we're meeting the Paris Agreement. And so these things are neat, but they're more like hobbies. How do we get there at mass scale fast for the drawdown? And we have to start putting that filter on everything, because we don't have the luxury of time anymore.
Okay, just one more, which is from a poll that I did on the YouTube page where I asked about some of these. I haven't got yet to rooftop wind and solar windows. So I think we're all sold on rooftop solar. It makes up 10% of Australia's electricity generation these days. So that's pretty significant.
Awesome. Yeah.
What do you think about rooftop wind, solar windows? Are either of them worth the effort?
Yes, I would say yes. Wind is a monster contributor to renewable energy. In certain countries, it's huge percent of the total. It's bigger than photovoltaics. And I think you should go for wind wherever the economics work and the production is good. It's not good everywhere. You need a certain miles per hour. Here in the US, I think it's 6 or 8 miles per hour for wind to make sense. Sure, why not solar windows, integrated PV, DIPV? Absolutely, it's surface area. All surface area should generate. And I think it makes good sense. Why we don't see it more? Probably economics, and maybe hasn't been cracked yet. I've seen lots of products and some companies who are doing it in Israel and other places. I'd say yes to both.
Yeah. Okay. And solar windows, have you seen anybody using those? To me, it seems like a lot of faff for minimal additional gain compared to just putting as much as you can on your roof. But
we're tapping out. You can't get to net zero on most roofs unless it's single story and a mile long. So you need more surface area. So solar windows, I say absolutely yes. The building integrated PV, I think it'll be there. I haven't seen it hit mass adoption yet, but I've seen products that work.
Yeah, it'll want to be reliable. Otherwise, it will just be a gimmick.
They make them now reliable, but it just hasn't cracked the codes yet. I worked with one firm that had, it wasn't solar, but they had windows that self-tint, electrochromatic, and those make sense also because you can insulate through the window and limit the heat gain and the glare. But why not do that and have it generate clean, renewable power? I think it'll be standard in some period of time.
I haven't seen any actually up close, so I'll keep an eye out in the future. All right, we're very, very close to running out of time. Just got a couple of questions and then one more for you. So, a couple of comments from viewers. Helen Lawson says, my old boss lived in a Cob house down near Exeter in the UK. It was about 200 years old. I mean, that sounds sustainable to me.
Absolutely. They last. They have good structure. The thermal mass is phenomenal, and the R values are very high, and they insulate. And there's a nice aesthetic feeling to it too. So sure.
Yeah. And then from Super S05, one of the biggest issues with more sustainable buildings is that the people that build things are not the same people that will buy it, and often different again from those occupying it. And that's something I've noticed in my house hunting. So many times I come across buildings houses that have just been renovated, that, they just look brand new on the inside, and the energy efficiency, they got 0 stars. And, often the rating goes down after the renovation compared to before it because, they put in extra south facing windows, take away all the curtains, that sort of thing. And I find it super frustrating.
And heaters too that are inefficient. Yeah.
Yeah.
Well, we can do less square footage, much better house if you let the daylight in, but then, insulate it off the charts. The first thing I always want to do when I do a house is super insulate it and get the daylight in, but have quality windows, because the window is not a high R value like some of the walls we could do, but we never insulate enough, and we never have the right overhang shading. Almost no structures go out far enough with the shading.
Okay. All right. We didn't get to everything that I wanted to ask you, but just one final question about the future. Do you think we're focusing on the right issues, or is there something big that we should be doing that we're not, whether that's technologies or regulations? I don't know if there's anything in the Inflation Reduction Act about buildings. What would you pick out as the biggest thing that we should be doing that we're not currently?
Waking up more. I think that we're just, with everything we're doing, it's not enough. We're out of time. We have to wake up. We need more massive amounts of money, like $1 trillion investing in this, with new forms of investment, with aggregated procurement to drive the plants of the future to get to the gigatons. We have the carrots, we have the sticks, but the volume is still too low. We have the COP meetings, and all we do is run around and celebrate. But every year, the UN measures what happened from the last year, and the slope is still ridiculously slanted up. And we're not getting there. We're not working well enough as a world. We're still country independent. The climate change doesn't care where your line is of your country, and we're out of time. And so the best way to drive this is money, massive money, new forms of investment, new forms of procurement, new forms of aggregated purchasing. And it's got to go in advance with GPOs, group purchasing organizations. And it has to be focused on the gigaton solutions. And we have to wake up. We're not getting there fast enough. We're just not. And I think it goes to our brains. We need more neuroscientists to work with the sustainability people, so that our survival wiring of the past that's killing us through greed and excessive stuff wakes up, so we can have, through plasticity, new survival wiring that allows us to sustain and regenerate. And everyone could have, as Buckminster Fuller said, we need a global awakening, man. And we're not getting it. We need the therapists, psychiatrists, neurologists to work with the sustainability people.
I think that's a really good thought to end on. So I'll just wrap up. I've got to thank again the sponsor, WeatherGuard Lightning Tech, for sponsoring the live stream. And WeatherGuard also have a great tech newsletter and a podcast, which I co-host with Alan Hall and Joel Saxum each week. The links to all that is in the description. We talk about all kinds of clean energy tech news. And in the latest podcast episode, we talk about floating offshore wind. The world's largest floating offshore wind farm just was commissioned off the Norwegian coast. And also wind turbine drivetrains and how to avoid using rare earths in them. Next Engineering with Rosie video will be on aluminium, coming out sometime in the next week. And the next live stream will be another big high profile guest like today's, Michael Liebreich. So if you've got questions for that, then get in touch. And other than that, just need to give again a really huge thank you to David for coming on. Got so much experience, and it's really interesting to hear how things have evolved over the course of your career, which has been long so far. Hopefully continues a fair bit further into the future, because we need that experience. So thanks so much.
Thanks for having me, and thanks for caring and asking the right questions and pushing. That's what we need.
Yeah, and I think that thanks also applies definitely to everybody watching, everybody in Engineering with Rosie Patreon. If you want to join us, then link is in the description. Big thanks all around, and see you in the next video.
Okay. Goodbye, everyone. Thank you for your great work.